And the cat thanks you. His name is Cloud, the pretty white cat. The black and white guy is okay. He's lower maintenance. And we start. Voila. We left off. This is super important. I'm going to show you a slide on the other PowerPoint that's great. It gives you everything you really need to know about these and how we use them. So these are called quaternary ammonium compounds, or quats. They're technically quaternary ammonium salts. So the detergent you're using, for the most part, unless you may be using some different kind of detergent now in the washing machine, those are negatively charged. Understand, most of the mass, you want to get technically into it, they're bipolar. So in a sense that they will be both water soluble and they'll adhere to the typical things we try to wash out, grease, grime, those kinds of stains. So negatively charged ones typically are phosphate based, and they're problematic, and positively charged ones are much more surface friendly. You don't get sick from contact with them. They don't absorb, if you will. So they're cationic, positively charged. They've been around for a long time. Years ago, when we use tincture of iodine and we use tincture of methylate, which were an alcohol that stung, they came up with something called, the generic name, the trade name was Bactine. Oh, it doesn't sting. And basically, it was a quaternary ammonium salt. It's been used for forever. And the beauty of it is that it doesn't lay on surfaces and provide a nasty residue. So when you go into Giant Eagle and it says Lysol wipes or Clorox wipes, they don't got Lysol, they don't got Clorox. Okay, they have this stuff. Because there's no odor or smell. Can you imagine how many times you see people, they wipe their cart off, heaven forbid, and where are you going into? Fruits, vegetables. The last thing you want to have is Clorox on your hand. I don't like that apple. I'll put this apple back. Now you got Clorox on the apple. Can you imagine what that's like if somebody doesn't wash it off? Yeah. Don't all of a sudden go in and sue they don't want that. So you're using on some restaurants, when they wipe down tables, this is what they use. Because it does the job for what it's supposed to do. Take easily vegetative bacteria, envelop viruses. They'll do a more thorough job most places after all the tables. Basically in a restaurant, you'll see the way that they do things that are there. They're probably what we call turning them about 3 or 4 times. That's a lot. Like over dinner. You want to think of the way it is. There's a whole lot. If you're like me, a compulsive foodie, these are the kinds of things. Very low toxicity, great for food prep surfaces in between, or even the counter if you're going into a place that had like a counter space where you might get food stuff. Okay, and so you have charged and uncharged reasons. So when you talk about surface tension, effectively that's like what we call a wetting agent. It's the thing. It's like your soaps that you're using, whether it's laundry soap or dish soap, except those are the ones that are negatively charged, okay, as opposed to positively charged. That's the big difference. It's not a big deal that you have to know that. I'm trying to give you the science behind it. So it can bond to the dirt, the organic matter, and the organisms, and we let the water or the mechanical action wipe it away. Okay, voila, vegetative bacteria, not naked viruses, lots of personal care products, just like iodine. I mean, it's not that strong, so we can see Pseudomonas even, so it's not 100% desirable, but it's useful. We're almost done with these. I'm going to flip back to the other PowerPoint so you can kind of see what's going on. Okay, this is that chart, Sydney, that I referred to. All of this stuff. This is the famous chart. Alcohols, aldehydes, because we do it by category. So it just summarizes everything nicely. All the stuff you have to know. The one that they didn't spend, again, this is an interesting one. It's relevant historically. Oh, it's about my granddaughter. It's okay. It's a good thing. Distraction. Okay. So if I'm trying to remember if we commented on, but I know basically, this quaternary ammonium salts replaced this triclosan. Years ago, it was hexachlorophene. Very effective against Staphylococcus aureus, but the trouble was, there was accumulation in tissue. This was a neurotoxin, So effectively, it gets removed. And again, this was the one that Lister used initially. So that's one's useful historically, and you do need to know those things. You see, a lot of times you've got whatever job you're doing. If you are involved in this, and depending on what your role is in your careers going forward, it's going to be up to you. What should we use for this particular job? How will we sterilize it? How will we disinfect this? Whatever. So now this is really much the end. Again, this is more food science than anything else. Okay. If you look on anything that you might have with you, or you go, you'll see chemical preservatives that are in there. They're designed for that, to extend shelf life. The less you have of them, probably the better it is. Okay. So, I mean, that's why, so most of us don't give it a second thought. If you're going out and whether you get a Coke or a Diet Coke or a Pepsi or a Diet Pepsi, you're probably not thinking about that stuff, but they're there. So a lot of times when the lesser exposure that we have to preservatives, probably the better for us for long haul. So typically what they do, they have to be non-toxic and safe for ingestion. I'm not saying they're necessarily bad, but understand what their role is. Okay. And so they alter cell membrane function, they control molds and bacteria, so it's limiting things. So it'll say, they're called benzoic acid, sorbic acid, propionic acid. When an acid goes into water, we give it the name ATE. ATE is an acid that's been in, so it'll say sodium benzoate, potassium sorbate, calcium propionate, those kinds of things. So when you see that, you'll know it's a preservative. That's what it's there for. There's nothing wrong with it, because we buy prepared foods, we buy shelved foods, we buy canned goods, we buy frozen goods, all of those things. So it's up to you. You know, my feeling, and this is personal opinion, if you can limit it, limit it. Okay. Like other than having some flowers for decoration, most anything that we plant, we grow so we can use. Our house, that's us. Okay. That's us. These are interesting. They provide, we see this in processed meats. Historically, potentially these are problematic. Notoriously, it was hot dogs. So a lot of times you'll see, if you're having a picnic and you're cooking out, you're going to have hamburgers and hot dogs. Most of us are. Sometimes you want to get the hot dogs that are uncured. They won't have these. It is, again, it's cooking science. There's something, we use pink salt at home, Himalayan pink salt. Buy it everywhere. Very popular. If you see the term pinking salt, that's not the same thing. That is called potassium nitrate. That's a preservative. And what it used to be called saltpeter. It's actually an ingredient in gunpowder, if you want to go into the history of explosives. Don't ask me why I'm a fountain of useless information, but I am. I retain stuff like that. You put that in, like when you're making corned beef, okay, or pastrami, you put that in because it gives it that pink color. And people like to see that. They associate that with freshness. Don't know why, but that's it. And so as you can see, and it has a very, very useful role because it inhibits endospore things that are going on. So be watchful of those. So it depends. I mean, if you're ingesting a tiny amount of those things that have it, don't worry about it. Okay, but that's where you're seeing a lot today about. You'll see uncured products. Uncured means you better make sure you cook them thoroughly. That's the other thing. Because a lot of times when you get a hot dog, all you have to do is warm it up, really. More than it's already cooked and cured, so to speak. And that's a different thing. It's like my wife is offended by things like, she tasted it. I have a fondness for smoked salmon. It's a genetic thing. Jewish people love lox, which is cold smoked salmon. And so they had that out at Costco. And she ate it. She goes, "This is delicious." She goes, "This is raw fish." I said, "No, it's smoked and cured." So they cure it, which means they salt it and flavor it and sucks out all the moisture. That helps with, but that gets rid of the bacteria, and then they smoke it, but at a low temperature. Typical smoked salmon is hot, but still it looks like raw fish. She wouldn't eat, which is fine because I got to eat. That's right. Okay. The next time you have an hors d'oeuvre with creme fraiche, smoked salmon, and a drop of caviar. You don't like it, you know what you're missing, I'll take it. Bring it back here. Just a hint. Maybe a little Ocetra caviar. You'll get there. So the most common way that we store things, refrigeration. Does it really do anything? It just slows things down. So things that like the cold and things that adore the cold can still grow. And so the problem with freezing is, I said to you, ice crystal. And the trouble is 1 state to 4. So it's a function of time. Is it useful? Sure. All the time. Like I said, we are in love with refrigeration. But understand, it's not, make no mistake, it does not destroy anything. It merely slows down the growth cycle. Okay, and then sometimes, particularly with freezing, if you don't freeze it properly. So historically, what was a better way to do it was freeze drying. It's not something that's done. They used to advertise stuff as this freeze dried coffee for instant coffee. I said, so I think it's still used commercially, but to what extent I don't know. So this is the reducing, salting. This is what curing is: salting, sugar, drying food. We have a food dehydrator. We used it to make soup. We had dehydrated vegetables and stuff like that. And, you know, we threw it into like a chicken vegetable noodle soup that we made. I mean, that's been sitting there for at least since last summer, but dried in a jar and it was fine. And so all of those, they're going to, again, so just think it's osmosis 101. You're in a concentrated area, pulls water to it. So understand, Staphylococcus aureus is a problem with regard to some of these things. The big thing to take home is this, okay, is when you're jarring or canning or doing any of those types of things, acidity is your friend, because botulism does not do well in an acid environment. So when you have tomatoes from your garden and you're making tomato sauce or just whole tomatoes that you cooked and skinned, they're fine. Other stuff, not so good. So you have to be very watchful to know what you're doing with that. So there's a lot of things where there's things that are freeze-dried, as you can see. They'll supplement it by salting. This is interesting. There's no C in there, obviously. So that, you know, there have been cases of that with dried eggs. I mean, it makes me wonder if now, with eggs so expensive, that people are using those kinds of products more. I would be watchful and make sure that they're cooked thoroughly. To tell you the truth, if people were inclined to do that. I mean, we had eggs out. We decided to, you know, throw caution to the winds money-wise and use 3 eggs. Eggs, expensive, you know, like $6 for a dozen and a half. Oh, thank God that was over. Here, I'll show you the rest here. This is the interesting part from the other PowerPoint. And I like their graphics here. Same, you know, same. It's still McGraw-Hill, and McGraw-Hill is interesting. Okay, so look at it, chlorine, and you can take a look at how rapidly these are hard to get rid of. Okay, so when you're dealing with tuberculosis, you need 50 seconds. And think how quickly you wipe down that table in the lab when you spritz it with dilute. That's no 50 seconds, and it's sure not 2.5 hours. So understand, there's some certain limitation. Is it useful? Is it something that you should be doing inside of a laboratory where you really want to get a little bit better coverage? But understand, the time is significant. And with alcohol, we never have it on for this long. Okay? So you're having, it's not nearly as efficient as you think it might be. Okay? And to say now, peroxide, notice, you're looking at all of these things. Peroxide is very efficient. I do not, you may be doing it in lab this coming week, because I saw Mrs. Maurer was making these big plates. Maybe you saw them. We use a lot when we test antibiotic discs, and we test, and a lot of times we'll test, I do, we test disinfectants and antiseptics. So I get different things out there. I get iodine, I get peroxide, I get alcohol, I get those kinds of things, and allow you folks to use certain bacteria so we can test it to see how efficient or inefficient it is. And we certainly, those quats that I was talking about and those wipes, no 10 minutes. So the peroxide is pretty efficient. And you see, when you get to the laboratory, you will see how efficient peroxide is if indeed you're doing that lab. I mean, so a third of a second, not too bad. Now, gonorrhea is a very, very fastidious bacteria. In other words, if you look at it cross-eyed eyes, streptococcus is like that. Okay? Staph aureus is a pretty hardy bacteria, and these are enveloped viruses, surprisingly enough, but still it's a matter of seconds. And so now understand, when it comes to that poison gas, this is called Streptococcus faecalis. It also goes by the name we're talking about it at length, called Enterococcus faecalis. It is a real pain in the neck in a hospital. You'll start to hear the acronym a lot, called VRE, vancomycin resistant enterococci. That's another name for Streptococcus faecalis. It's a different group, and obviously influenza, but this is with gas, we're exposing it not for minutes, but typically for hours, making sure. And there's considerably less worry about viruses with regard to that. So again, here's that very similar table, and you can look at either one of them. Halogens, be they chlorine or iodine, okay? And you can take a look at all of these things that are there. Oxidizing agents, this is where the hydrogen peroxide, principally aldehydes, which we talked about initially. And you can see what it's sporicidal only in high concentrations, that's that vapor phase. Aldehyde, okay, and you can see there's some limitations with glutaraldehyde that I used in the office for many, many years. Here are the gaseous agents, here are the phenolic compounds that are there. And this is in many phenols banned in consumer products in 2017, including particularly that triclosan. Maybe you shop the way we do, and something's on sale, you buy a bunch of them because you like the product, and you stick them somewhere in a closet, or we put stuff downstairs, and you forget about it sometimes. You go down and get a thing of antibacterial soap, maybe you find an old one that'll say contains triclosan. Not unusual at all. I mean, it was 7, 8 years ago. It's not a long time comparatively, but now you'll see they have mostly quaternary ammonium salts that are there. Here's the chlorhexidine. They call it chlorhexidine. Classically, they're called biguanides. You'll see on the exam, hint, there's a question about it. Okay? It's on the exam, okay, I have biguanides and then in parentheses chlorhexidine, so it won't confuse you. You have to thank me, it's all part of the service. And again, the detergents I really didn't comment on so terribly much, other than the quaternary ammonium salts. Okay, so I mean, these are a little bit different. So the quats are in there, but I refer to them as quaternary ammonium salts. The metals we talked about at length. And again, this was the benzoic acid, all that happy stuff. So again, we play a role with dilutions of the liquid chemicals diluted to a large volume of solvent to achieve a desirable ratio, whatever that tends to be. And so if you're doing this in a hospital environment or an office environment or in a clinic that you may be managing, an outpatient facility, I mean, the instructions are going to be there on the material. You just follow them. They're there for a reason. When you don't follow them or have your staff follow them specifically, you can't ensure they're going to work the way they're supposed to. That's why they put them there. Okay? So, and these are the kinds of things that we look for. I was telling my lab briefly that EMB agar, it's used all the time because it really identifies gram negatives. The biggest contaminant in water is fecal material. It's filled with gram negative organisms. Okay, so we realized that the water we drink, city water that we might get here, has been treated chemically. Okay, and sometimes it's treated with ultraviolet light, sometimes it's treated with ozone, it's filtered, as well as being treated with a variety of chemicals. Okay, there's an allowable amount by law of how many we would see, and that's when you do those dilutions that I know Dr. Dress's lab did, I did not, and you do colony counts. Is that something that's familiar to some of you folks with Dr. Dress? Okay, I didn't do them, and you get what's called a countable number. And you see, I forgot to bring my marker. Sometimes you'll see hardly a smattering then you maybe have over diluted. We call that too few to count. What you don't want to see is after you dilute it, is seeing a whole ton of them. That's called TNTC, too numerous to count. You'll hear that expression when you have patients and you'll get lab tests back when they've done what's called a urine culture and colony count. I mean, a lot of times there's bacteria in the urine. You heard me say that. We do a colony count because sometimes it just has to do with it. When it wasn't a clean catch specimen or it was a contaminated specimen. When you do a colony count and you get vast numbers of bacteria, big trouble. That's called TNTC. But a countable number is between 30 and 300. Like you take a quarter of a plate, if you have about 50 organisms or so, 40, you count a quarter, multiply by 4, a third, a half, whatever. Okay, get the idea? There's acceptable levels, and we look for acceptable levels of E. coli and things that look like E. coli. We have a great name for them. They're called coliforms, coliforms, gram-negative bacteria that are sort of in the E. coli family. They're gram-negative, and they ferment lactose. Lactose is the big player. And so you look at that, and EMB selects for them very, very nicely. And then you do the colony counts. That's what they're doing in water treatment facilities. I mean, they've got to find a way to standardize that you can be comfortable. It may not taste great. I mean, I don't know. Who was doing the water? I lived near North Hills Pasadena Hospital. I mean, the water was perfectly safe. It was the worst tasting stuff ever. Terrible. I lived in an apartment in McCandless Township for about 5.5 years before I got married again. So, adequate contact time, that's something that you need to understand why you're not sterilizing the surface. You know, again, if they tell you in nursing, sterilize the surface, okay, I got it. I'll get the bleach out. Don't say anything. So you got it? How the composition, etc., things can get trapped. You have to look at all of these things. Again, stuff on there, organic material. Okay, cleaning of instruments, reusable materials must precede the use of any of these. I can't stress that enough. The first thing you learn. This is that slide. I love this slide. Lysol wipes and Clorox wipes. Dimethyl benzyl ammonium chloride. That's a quaternary ammonium salt. That stuff that I talked about, the Bactine, that's what it was made out of. Okay, so it's not, oh, it's a Clorox wipe. We're not in trouble. Oh, come on. Soap and water would probably work as effectively, but you wouldn't want to have the taste of soap if you were going to be anywhere touching the consumer. Okay, understand that. Now, here are the bleach. Mildew remover, Tilex, Lysol. Lysol is not a phenol. Why we read the label. Lysol spray. Oh, I'm going to disinfect with Lysol. Again, quaternary ammonium salt, some alcohol. Who cares? So, contact lens solution. Biguana, it's chlorhexidine. So, let me get through these. I'll give you the go back to the contact lens. Mouthwash. Now, again, no phenols are in it. Originally, now it's just an alcoholic compound with whatever, something they'll put in it, whether it's menthol or a certain flavor. That's sort of, when it's scope, it has a certain flavor. I mean, I have my toothpaste this morning with scope in it, some kind of crest with scope. Purell, alcohol. Okay, some are detergent based. Okay, eye drops. Now, these would be a very, very, very low concentration of that, because otherwise they would be certainly dangerous. One of the biggest single problems, I may have told you that before, the #1 contact lens overnight solution was made by Bausch & Lomb many, many years ago. I want to tell you, at least 15, 16 years ago. They ended up, and they had never had a problem, ever. Okay. In the history of this company that was in Rochester, New York for forever, my sister was, when she retired, was a vice president in a different in ophthalmologicals. She was in a division that handled Ray-Ban sunglasses before they sold that. Nevertheless, she's approached a marketing specialist. their facility was in North Carolina. Something bad happened. Wasn't clear. Fungi are really the culprit when it gets into this. So they had a batch that came out of this #1 solution in the United States. 5 people lost eyes because they got a fungal infection that they couldn't do anything about, and just, at least a couple they actually had to remove eyes. Imagine that. It doesn't take much to make a mistake in industry. I mean, even with a company that was like that, I mean, it had tremendous implications for that. They formed a team to basically get out in front of it, from identifying it, making sure people were taken care of, trying to reassure people that, we know this is our mistake, we're going to own it, we're going to do everything, that kind of stuff. How you try to handle problems in a business world. It was very, very interesting. Very, very interesting. So it's easy. Now that's a monstrous thing that happened because of an immense amount of products. In that, it doesn't take much on your end if you pay. I'm not saying that they played fast and loose, but if somebody makes a mistake or you make an error, you get the real story. Make little ones. 53 of you washing their hands with soap and water between 6 and 20 times. 62 done with 40 pairs of gloves. This is giving you an idea. Studies conducted before the onset. Soon there may be studies to show how healthcare civilians changed their hand hygiene practices and how that impacted the skin. And that's what I was telling you. The people who are in love with those things. The most important thing to me is the more you use these, alcohol dries, it evaporates. Now, some of these come with moisturizers. If they don't, and as you get older, your skin dries a lot, particularly if you're fairly complected. And I'm looking at a room that has a lot of fairly complected people. Okay. You got to be mindful of your skin, because think of how many times you're going to be putting on gloves and using alcohol and washing your hands over time. I told you, my first wife was a nutcase. Another one of these RNBSN nutcase. Go figure. Joking. She was an obsessive hand washer. Her skin was so dry. I'll tell you how. We had 3 kids in diapers. So let's say my wife's ex-wife's first name is Bonnie. Yeah, so maybe she was 38 or 39 years old. She got to the point where the cracks and splits were so bad during the winter that she had to wear gloves. She could only wash her hands. The dermatologist gave all sorts of products. She had to wear gloves constantly. She was allowed to wash her hands 3 times a day for 3 or 4 months. Other than that, was washing the gloves. So your skin can be, and this is before. This is 1989. This is the better part of 40 years ago. Imagine what it's like today with this obsession we have with hand sanitizer. Please be cautious about it. I'm not going through all that. Oh, so we're blessed. We're done. Thank you. Now what are we going to do? So no, let's see what time we have left. We have plenty of time. All right, I forgot to bring, I don't have anything really to load with it. There's a couple of little things I saw on the exam that I thought were relevant that I think we need to discuss. And there's normally I include 50, are you ready? There's 5, I beg your pardon, an answer, Brooke, 55 questions. There are 5 questions that are genetically based. Normally are 65. On average, students would get about 10 of those wrong. So I kept the 5 most important ones in. They're about genetics. So I de-emphasized that unit. That's the unit that talks about certain genetic mechanisms that facilitate how bacteria can change over time. Remember, I talked about that a couple of times. How plasmids. For whatever reason, it's not essential for you to understand. I will upload some animation so you can see how it works. But I don't think it's really necessary for me to ask these things about the F plasmid and what it contains and how it moves, and the difference between conjugation, transduction, and transformation. We're ready to name. You want me to go into this?
On the test?
No.
No.
Skip it.
Yeah.
Look, test. It's a pick on Brooke day, as is everything.
It hasn't happened in a while.
I apologize. You're suffering from attention deficit disorder. I'm not giving you enough attention. That was good. Basketball team won last night. Hey, you can go someplace. I wasn't watching the game, but I was watching the score. He was getting past my bedtime. Really? Okay. Why are we worried about this? Okay. One thing you have to understand is something called the Ames test. Capital A-M-E-S. The Ames test has to do with a particular kind of mutation. What is a mutation? People misunderstand what a mutation is. Mutation is an error in DNA. All it is. It doesn't imply that it's going to cause cancer. It doesn't imply it's going to be deadly. It doesn't say anything other than an error in DNA has been made when it's being replicated. Okay, that's all. Something has come into contact with it and damaged the DNA. Either the DNA, the original, or DNA when it's being replicated as cells divide. Okay. The price of you and I probably make 1 billion cells in our gut every day alone. Easy. We probably 1 or 2 of them are mutated. Okay. Understand, we call those are called spontaneous mutations. They are normal. Our immune system, we have a lot of mechanisms. Our immune system, which we'll look at in anatomy and physiology. The mechanism of apoptosis. In other words, there's a mechanism within the cell itself that if it turns out it's either mutated or likely to become mutated, it just doesn't get replicated. Okay, control all those, so you don't have to worry about it. So there's a lot of things. We have a lot of controls. Just like whether you get a cold, or whether you get the flu, or whether you got norovirus, whether you got a strep throat, it's a numbers game. We are constantly exposed to these things. Okay, so mutations, we are constantly mutating cells, but the numbers are typically so small unless you do something to create more of them. That's called an induced mutation. I've exposed myself to the sun constantly. Ultraviolet radiation can damage DNA directly. Okay? We talked about it, thymine dimers. A definite way that they make those little sort of like the zipper can't open and close, thymine dimers. If you are in an area where inadvertently you are exposed to radiation, okay, let's say there was a failure at the place where you were working at a hospital, let's say, and your unit was next to radiology and they weren't doing their job, all of a sudden you could inadvertently be exposed to what we call ionizing radiation, X-rays or gamma. Not even thinking about something terrible like an accident a la Chernobyl or something like that, where you're dealing with something that killed a lot of people despite what the Russian, the Soviet Union government thinks. If you haven't done so, watch a wonderful show on HBO, which now is Max, called Chernobyl. 5 episodes of absolute unbelievable brilliance. And one of the best things I've ever seen. Moving on. So those are called induced mutations. When we expose ourselves to things that can induce a mutation, increase the likelihood of a mutation by a factor of 1,000. Okay, our cells, like I said, what's the typical mutation rate? 1 in a billion, 1 in 100 billion, not too many. And so the less you do inadvertently or by intent to expose yourself to things that could be damaging, the less likely these are going to be problematic to you, because you have to run the risk of increasing them by a factor of 1,000. Bacteria are not so lucky. They are inherently genetically unstable. Our cells, we have the beauty, we have what? Our chromosome is in pairs. We went over this earlier. We have pairs of chromosomes, dominant and recessive. So if a mutation occurs and we have a dominant and recessive, let's say, so we either have dominant, recessive, recessive, dominant, that's the most common type of thing that we see, and it occurs on The recessive one doesn't matter. It's a tree falling in the forest. Did it make a sound? Nobody was there to hear it. Okay, we call that a silent mutation. So there's a lot of mutations that occur that don't affect us. Yeah, unless you have both recessives, and that's the recessive that's expressed. But I'm not going to ask you that question. I'm just trying to give you some basic genetics. And you got to understand, down the road, you're going to get into pathophysiology, you're going to get into different kinds of diseases. We're going to talk about autosomal dominant, sexual recessive, okay, those kinds of things that are there. So you end up with, look what you have: dominant recessive, recessive dominant, double recessive, right? So if the mutation is here, or here, how can I get expressed? If it's here, it's 50-50. That's going to get expressed. There's only one of those gene pairs that are expressed.
So we're a little confused here.
Yes.
So in your video,
which is why I don't do this.
In your video, you said the Ames test was something about like the food.
Exactly. I'm getting there.
Well,
okay. So there's spontaneous mutations and induced mutations. Okay, bacteria are genetically unstable because they don't have pairs. They have one big circle. There's no dominant and recessive. If it's a mutation, typically it's expressed. There's other factors that are involved. That's part of it. So when we have, this is a strand of DNA, and it just occurs at one spot, one alteration, one A, T, G, or C, we'll call that a point mutation. Usually bad things don't happen. So if it's like that, if it doesn't do anything, it's called a silent mutation. If you think of what sickle cell hemoglobin is, that error caused an incorporation of an abnormal amino acid in a long strand of hemoglobin. Okay? That is called a missense mutation. And if you have an error that causes it to, maybe, I don't know how much you know about how things are assembled, things called stop codes. In other words, if it hits a particular genetic sequence that says stop making the protein, okay, we call it a nonsense mutation. That's why I don't include this. Okay. There are mutations that are so severe, it can take something that's mutated and totally reverse it to non-mutated. Now, why you might think that's useful, I agree. If we could magically take something nasty in us and reverse it, would be great. The trouble is, we've never found any way to affect that. Okay, we call that a reverse or backwards mutation. It's such a strong kind of mutation that typically an agent that has that capability to do that to bacteria will cause cancer in us. Get the idea? So something that could cause a reverse or backwards mutation in bacteria is likely to cause cancer in us. So the Ames test, to answer the question, takes a strain of salmonella that has a mutation, which was an asterisk next to it, a mutated, exposes it to that chemical, whatever it is, that chemical or that material, that agent. And if it can change it back to non-mutated salmonella, okay, that chemical agent is so severe, okay, it's going to cause cancer in us. That's the Ames test. The Ames test takes, you don't want to test it on people, and you don't want to test it on animals, okay? So we found the bacteria. We found a mutated form of salmonella. We put it in a mix, some of this bacteria in a mix with a nasty chemical. So everything is tested by the FDA. Any consumable product, any pharmaceutical product, any topical product is tested, has to pass the Ames test. If it passes it, here's what happens. They mix it with that bacteria. They add some enzymes from typically a rat or a mouse, because it needs human enzymes. You don't have to worry about that, to activate it. And then if it doesn't alter the salmonella, if it doesn't backwards mutate it, that means it's unlikely to cause cancer in us. Okay, it passes the big test. If it does cause the reverse or backwards mutation, that's such a nasty agent, is likely to cause cancer in us, and that's called failing the Ames test. We're not going to have it. It's not going to be something that the FDA is going to let loose. You're getting the idea here. So you fail the Ames test if it backwards mutates. You pass the Ames test if it doesn't. The strain of bacteria is salmonella. Those are the two questions. Could this be any harder? And then silent mutations, induced versus spontaneous mutations. Are we good? There's other things that are involved. How bad is my time? You're not getting that answer yet. So to understand, I'll show you some of these animations, and it probably wouldn't hurt Monday if we chatted about them a little bit. Again, I found that every time I put that on the test, it was like the last 15 questions, and typically students were getting half of them wrong. Yes?
This isn't about this.
Good.
But, you know, in the video, you said we had to know all these viruses that are on.
Yes.
Like that, do we actually need to know all of them, or are only some of them on the test? Because, like, that's a lot of viruses. Right?
All right. I will review as a favor to you.
Okay.
I will review and I will clarify if there's anything on there you don't need to.
I like that idea. Thank
You don't have to ask me. There's no extra. Go to the casino. Have somebody go to the casino. Chips. Nobody will know. Be our little secret. All right, let's go. Goodbye. I'll have to scrub that.